pulley system is a way of gaining mechanical advantage. That means we can do more work by using less effort. Let's see how pulley system work in action. Before we can understand how pulley system work, we need to know a few principles. First, if this is the ceiling and we attach a rope to the ceiling and we pull down on the rope, and the rope will also pull down the ceiling, since the force is transferred through the rope to the ceiling. So we are actually using the rope to pull down the ceiling. But according to the third law of Newton's third law, any force applied on another object, the other object will also apply the same force but in equal magnitude but in opposite direction. So if we want to pull down the ceiling using the rope, then the ceiling will also want to pull the rope on using the force of equal magnitude but in opposite direction. That means this is also the force that the ceiling is pulling up on the rope. That's why when we pull down the rope, we don't see the rope will keep pulling down the ceiling, as ceiling is also applying an equal but opposite force on the rope. So the rope is stretched and have tension within it, and this is only true when the rope is stretched at its maximum length. So the force applied on one end of the rope can transfer directly to the ceiling, and the ceiling will apply the same force of equal magnitude but opposite direction. In this case, we are pulling down on the ceiling, so the ceiling will also want to pull back, so the ceiling will pull up on the rope, and the rope appears to be frozen in motion. So the rope doesn't move, but we actually apply a force that is countered by the normal force applied by the reaction force from the ceiling. And this is one of the principles that we are going to use. And another principle is, here is the ceiling and this is the pulley, and if we have the rope attached to the pulley, which is also attached to the ceiling, and if we want to pull down on one end of the rope, then the other end of the rope will pull up, and since we are pulling down and the pulley will changes the direction of the force, and so that we can pull up the other end by pulling down another end of the rope. And this is what pulley does. It pulley changes the direction of the force applied on the rope. And this is the second principle. If we pull down on the rope on one end, then the other end will goes up. That means in the opposite direction to the force, the direction of the force we are applying. And the third principle is if we attach one end of the rope to the ceiling, and we have a pulley in the middle hanging by the rope, and that pulley will have some mass, and thus mass, anything that has mass will have weight, and the weight of the pulley is pulling down on the rope, and that weight is spread across evenly on the rope. So that means on the two sides of the pulley, the force, the magnitude of the force have to be equal, since the weight of the pulley is spread across evenly across the rope, the length of the rope. So at both sides of the pulley, the force must be equal in magnitude, and that means both forces, since if we sum up the net force on both sides of the rope, then we have to be equal to the weight of the pulley, and that means 2 times the force on each side, or maybe if you maybe much more clearly would be those are the two forces that is spread across evenly, and if we sum the two forces, since those two forces is equal to the weight of the pulley, that is the net force, so we sum those two forces, and we sum those and we solve for each force. What we will get is each force on both sides of the pulley are equal in magnitude, and is half the weight of the pulley. So we need to keep those three principles in mind when we are analyzing pulley systems. And now let's analyze the simplest pulley system. And there is a ceiling, and this is the pulley, and we have a weight on this side that we want to balance, or we want to use force to lift up that weight, or just balance it, just place it in position, or just make this stable so there is no net force on anything. Nothing is moving in the system, so the system is stable by applying a force on this side, on the other side of the weight. And here we want to remember, since the weight have weight, so it will pull down on this side, pulling down on this side, and the force on one end of the rope will be transferred around the pulley to the other side. This is our first principle that we discussed about. So if we pull down on one end, it will make the other end go up and in the opposite direction of the initial force. And if we want to make this pulley system stable, well, these two forces, that means if we let the force, this is the weight, and then this is also the weight here, we only have the weight on the left hand side, the force of the weight on the left hand side pulling down, and that gets transferred around the pulley to the other side, and then to pull up, you pull the weight pull down on one side, and the same force of the weight is pulling up on the other side, and we are applying a force in order to balance the weight. So these two forces have to be in equal magnitude in order for the system to have no net force in. That means the system is in balance, and that means the weight must be equal to the force. The magnitude of the weight must be equal to the force applied on the other end. In order to have all forces cancel out, so we have zero net forces and the system will remain stable. So this is the most simplest pulley system, but if the weight is heavier, then we need to apply the same force as the weight, and that is what we want to get an advantage is by using less efforts or less force to pull up, to lift a weight, and if we compare the force we need to put in, that means the force we need to put in and divided by the weight of the other end, and we find that since they are both equal in this case, that means the mechanical advantage of this pulley system is 1:1. 1:1, that means we have no advantage. This is the ratio of mechanical advantage. So if you want to know if a system have any mechanical advantage, you will need to find the ratio of the force you put in order to balance the weight on the other side. And in this case, since those two forces are equal, so we don't gain any advantage. And so what would we need to do in order to have an mechanical advantage? What we need to consider is a system of pulleys, and let's say we have this is the rope and this is the pulley, and the pulley has weight, and we are attaching this pulley with our weight, and this weight will have some force to the ground, and we want to apply some force to balance the weight. And we can see that this time the direction of the force is upwards, and since upwards is opposing the gravitational field, the direction of the gravitational field, and that makes our work done on the system need to be much more. We are putting more work to oppose the gravitational field, then we can put work on the system. So if we are applying force opposing to the gravitational field, then we will have an extra force needs to be opposed, which is the gravitational field, and that would make us put more effort in order to use any force, and that is not ideal, as we want to use as the minimum forces possible in order to lift the weight. So what would we do to the direction? What we would like to do is we would like to apply force at the same direction in the same direction as the gravitational field. That would make us much easier and use less effort and to apply any force. So how can we make our force changes direction from up to down? And that can be done by we can just add another pulley to the system, and by adding another pulley we can change the direction again. And as we can observe, the first pulley changes the direction of the rope from going downwards to upwards. Then by adding another pulley, we can change the direction of the force again from upwards to downwards. So by adding another pulley, we can make our direction of our force application align with the gravitational field, and that would make us use less effort to apply any force on the pulley system. So let's analyze this pulley system, and let's first start with the other end of the pulley system. Since the other end is attached to the ceiling, and if you see the weight, the first pulley, the pulley with the weight attached, and since the weight is spread across evenly on the pulley, and if you remember from our third principle, and the weight will have two equal forces on both sides, and those two forces need to add up together to sum up to the weight. So we know those two forces are half the weight, and if we keep the same logic and we see the middle of the pulley system, there is a force applying downwards on the rope. There is a force half the way applying downwards on the rope, and if you remember from our second principle, if you apply the force on one end of the rope, it will pull up the other end of the rope. That means Our force applying in the middle will be transferred on the right around the pulley to the right of the rope, and this force, since the force is transferred around the rope, so we know this force is also the same force in the same magnitude, which is half the weight. And now we see that there is our force applying downwards, and there is a upward force which is half the weight. And once again, if we want to make this pulley system in balance, those two forces must cancel each other out. So those two forces must be equal in magnitude. And so we can conclude that the force is equal to half the weight. And what can we see this time from this pulley system is that if we find the ratio of the force we put in and the weight we want to lift, and we just plug in and the weight actually cancels out, and what we left with, if we apply 1 Newton of force, we can exaggerate or multiply it, or we can lift a weight of 2 Newtons. That means we can use half the weight to lift up. We can use the force, which is half the weight, to lift up the weight. So this system, you can see, is having a mechanical advantage of 1 to 2, or we can just apply half the force to move the weight, half the weight to move the original weight. And now we have a system that have a mechanical advantage that we would like to use in order to minimize our work done, and thus we would have less effort to lift the weight. But we can actually do better than that, and that is how we can do. Let's consider we have this system which have a pulley which is like this, and we have the pulley in the middle. Which is attached to the weight, or which is partly attached. As the left, if we want to, there are two ends of the rope, and we would want to balance that, so we will actually connect those two ends, and like that we connect those two ends, and we have the weight balance in the middle. And from this, if the weight is split into two parts, and then if we let one part, if we let this part, if we let this part like holding a mass M, and the other part is holding another mass M, and this is just the weight can be split into two parts, like the middle is holding a mass M, and the other end is holding a mass N, which sum up just equals to just equivalent to our initial pulley system, just having to hold the weight in the middle. And if we break down a system like this, and we just use our first principle, that means there must be, since the mass M is in the middle, is holding the middle pulley down, and the pulley is spread across the rope evenly, so the force on the pulley must be equal in magnitude on both sides. And as we have seen before, that means we can split M evenly, or split it in half, and those two sides will have half of the weight of M, of mass M. And if we consider this is the weight of this is the weight that we want to lift, and we split it into two different smaller weights, M and N, and we just break down our system. We can just ignore the weight now and just focus on two smaller weights, M and N. And as we see now, the middle weight M has force on the pulley, pull down the pulley, and the force spread across evenly on both sides. And if we now see what is the force N is pulling, so N is pulling on this side, and N is pulling down on this side. And if we remember from our second principle, if we pull down one side of the rope, the other side will go up, will pull up, and we can see that even my line supposed to be straight, you can see that the middle two lines are see as straight line. And if we see that if we see the second line from the left, and one forces N is pulling up, and another force M over 2 is pulling down, and in order for this pulley system to be in balance, those two forces must be cancelling each other or the rope will slide to one end or the other. Since we assume this is a stable system, that means nothing in the system is in motion, including the rope. So all net forces of all parts must have a net force of 0. So this is part of the system, and it must also have 0 net force, otherwise it would be accelerated. And if we just see these two forces, they are in opposite direction, and in order to have 0 net force, those two will have to be equal to each other. That means M must be equal to M over 2, and we can rearrange this to be N equals M, and we find the relationship between M and N. And now we can replace. Now we can replace M with 2N. So you see M here. This is replaced with 2N. And if you see the 2 on the numerator and the 2 on the denominator, they cancel each other out. So this would be just equal to N. And same on the other side, replacing M by 2N, and the 2's cancel each other out. So after replacing this, and since M over 2 is just M over 2 equals N, and we can just find, since we have everything in terms of N, and we know that the two forces on both sides of the middle pulley add up to the total forces of mass of the M, weight M. So we can just add up these two forces, and since we know that these two forces is N, and if we add these two forces up, and M over 2, N over 2, which we now know as M plus N, which is equal to 2N. And on the other side, we know there is N. So now we know what N, the ratio between the middle weight M and the weight on the other end of the rope N, and the ratio between them is the middle is heavier by 2 times the weight of the other end of the rope, the weight. So now we know that since the weight in the middle is heavier, so we know that the weight should be closer to the middle pulley and farther away from the outside. And also, as we remember, we just split the weight into 2 different weights, such that it is equivalent to the original system, the weight. And we know that M is equal to 2N. We substitute that in, and we get that the weight is equal to 3N, which is 3 times the weight of the outside if we imagine we split the system like that. And now we can just keep analyzing. That means we have a relationship between N and W. This is the original weight. If we divide that by 3, and we would get that N is actually a third of the original weight. So now we have established the relationship between W, and we do that by splitting the weight W into M and N. And by analyzing the forces on the pulley carefully, we find a relationship between N and M to be this relationship, which is 2 times N equals to M. And by using the middle pulley, we sum the forces on both sides, and we find that it is equal to 2N. So we know the weight is closer to the middle weight, and and we using the original split splitting the weight in the two other weights, and we find that the n on the outside weight is equal to a third of the original weight. So now we solve for all the unknowns, and we can express everything in terms of the original weight. Now we can keep analyzing. Remember, we just analyzed on the first pulley only. Now we are on our way to our second, which is on the right side of the second. And on the right side, you see that the force m/2 right side m/2 is pulling on the rightmost pulley down on the left side. And if you remember from our second principle, if you pull one end of the rope down on the pulley, the other end will goes up as pulley is changing the direction of the application of our force. In this case, it pulls up on this side, and we know m/2 is just n by the relationship we established earlier. And n, we see that we saw by solving n, we see that n is equal to w/3, or a third of the weight. And we still have the force, which is the force we apply. And now you see the same situation again. This is the force we apply, and the pulley which is pulling up. So in order for this pulley system to be in balance, what we need is actually equal by making the net force 0. That means the two forces would be equal in magnitude, or we can just say that our force is equal to a third of the weight. As you can see, if you apply the same force pulling up as pulling down, then no forces will be applied, no net force. So no net force means the rope in the pulley system won't accelerate, and if it is starting from rest, and it will remain rest by the first law of Newton. Or if we had some initial velocity, it will continue that initial velocity, doesn't change its velocity. So no acceleration in the rope. And now if we analyze the mechanical advantage of the system, force we put in divided by the weight we want to lift, and the force we put in, we find that is a third of the weight, and the weight cancels, leave us with 1, 2, 3, which means we only need to apply 1 Newton of force in order to lift 3 Newtons of weight, having a mechanical advantage of 3 times of a third of the weight. And comparing this to our previous system, you can see that we are using less and less force to pull up our weight. And if you think that is the best we can do, then I can show you another pulley system that can do even better than any of our previous system can. So this system will have 2 pulleys attached to the ceiling, and what we can draw in our rope, like that. And the force will go down here, so, and the weight will just be balancing on those 2 pulleys, and that is our setup for this pulley system. It uses more pulley than before, but the more pulley we use, the more mechanical advantage we will get, as we will see from now. So we can analyze this pulley system like before. If we can just split the 2 ways into M and N like before, and we know that the sum of those 2 ways will add up to the middle weight of our original weight W, and we can see from our leftmost pulley, since the leftmost pulley is pulled down by this force of weight N, and the pulley, if you remember from our first principle, the pulley is spreading forces evenly across on the rope. That means both sides of the rope must have equal forces on both sides, as all forces are spread evenly. And you know that means half the weight of N on both sides. And if you look at our leftmost rope, which is attached to the ceiling, and there should be an equal and opposite force, as the force is N/2 pulling down on the ceiling. So, and if we consider the middle pulley also, and the middle pulley has mass F, weight M attached to it, and the pulley is spreading its weight M across the rope evenly. So we also know that the forces on both sides must also be equal, which is half of M, the weight of M. And if we just analyze from the left hand side, and we see the forces downwards is N/2, which is pulling on the ceiling. And from the first principle, we know that there must also be an equal and opposite reaction force applied by the ceiling to be upwards, so that the two forces cancel each other out, and no net force will be at the point of contact of the pulley with the rope on the left hand side. And if we consider the next bit of rope, which is the N/2 on the right hand side, and we see it is pulling the pulley on top on the left hand side. And from our second principle, we know that if we pull on one end of the pulley, the other end will be pulled up, and also with the same force, N/2. And if we see what forces are present, and we see two opposite forces present in the middle pulley, and which is M/N n over 2 upwards and m over 2 downwards. In order for this pulley to be in balance, so this is a stable pulley system, we would need those two forces cancel each other out, and by multiplying by 2 on both sides, we find that m and n are actually equal to each other. So in fact, the weight that we split into, n and m, are both equal in magnitude, or they are the same weight. And from this, we know that the weight must be placed in the middle of both pulleys. So now, since we know that both the m and n weights are equal, we can just express everything in terms of m or n, and we can analyze the pulley system. Continue from analyzing, we will see that weight m over 2 on the pulley is applying a force on the rightmost pulley on the left downwards, which means the forces from our second principle, we know that if we pull on one side of the rope, the other side will be pulled up, which means this side will be pulled up by the same force m over 2. And now we see that the force must be equal, so those two forces must be equal in order to everything to stay in balance. But now we need to find what is m, and from here, we know we are splitting W, our original weight, into n and m, and since now we know both m and n are equal, and we find that our weight is just 2 times the m. So after we find this, we can solve for m, which is half of our weight. So this means this is half of our weight, and this is also half of our weight, since we know both sides must be equal, as we derived from before, and we can substitute that here. Weight over 2 or weight, our original weight, over 4, which is a quarter of our original weight. And this is the force we need to apply in order to make this pulley system in balance. So if we analyze the mechanical advantage in this system, which is our input force divided by the weight that we want to lift, and put in and still the weight cancel, leave us with 1/4, which is our mechanical advantage in this system. And that means we just need to put in 1/4 of our weight in order to lift it. So we can have put in even less effort in order to lift up our weight. And if you see the pattern now, the trend if you see the trend we are going from only using one pulley in the initial case to, and with only one pulley we only get no advantage, as the ratio between our force input and the weight is 1 to 1. That means no mechanical advantage. And we see from our second pulley system, and we use 2 pulleys to pull up our weight, and this time we get a mechanical advantage of 1 to 2.5 of our weight of force can lift up our weight. So we still need to put in some force, which is half of the weight we want to lift our weight. And if we see our third pulley system, we use 3 pulleys to lift up our weight, which resulting in a third of our weight in order to lift up our weight. So we are having a mechanical advantage of 1 to 3, which is a third of the weight of force can lift up our weight. And we continue this to using 4 pulleys, and we see we have even more mechanical advantage, since we are only using 1/4 of force in order to pull up our weight. So we are using less and less force in order to do work, which is lifting our weight. And using more pulleys, we can actually use 1 over the amount of pulleys of force to our weight in order to lift up our weight. So if we want to lift up our weight using just if we want to lift up a heavy weight, which we can't just directly lift it up, we can scale the weight down to any fraction we like in order to be able to lift up the weight. So we are decreasing our effort to lifting up our weight. And by using pulley systems, we can have mechanical advantage of any scale if we continue our trend of pulley system like this in order to reduce the effort we put in to lift up our weight to balance the system. And this pulley system can help us in real life, and such as if you want to bring if a long time ago there is still no water that can be transferred to your house, you need to lift water to your house, and to do that you need to go to a well that has a pulley system like this, and you drop down the bucket. You can then lift up the bucket of water by using the pulley system, and you can have less effort in lifting that water. Even if you want to lift up a large amount of water, you can use more pulleys like this to put in less effort to lift the water up. And put into modern world, and how we travel in buildings is by using elevator, and the way the elevators work is also by using pulley system in order to pull up the lift. And by using pulley system more sophisticated than this, we can lift up many heavy weight, more heavy things too. And elevator is just one example, and another larger scale example is if before the building is built, there must be someone to build it, and the way the building is built is by using large components to build, and those large components can be very heavy. And how can we lift up such a heavy object to build a building is by using pulley system. And there are pulley systems on cranes that use pulley systems to lift up heavy objects in order to transfer them to the correct position and assemble the building. And even larger is if you want to know how the products you bought every day from shops are coming from. If they are not coming from your country, they are coming from somewhere foreign countries, and the way they will be transported to your country is by using ships. And those ships contain some large cargoes that would include many products that you will see in shops. And how do we, when those cargo arrive, we need to drop the cargo into a truck and then transport. The truck will transport those products to shops, and then you can buy the product. But how the cargo can be lift out from the ship then onto the truck? And the way to do this is also using pulley systems. And using pulley systems, we can lift up heavy things like this and transport them to anywhere we like. And so you have seen some examples of how we use pulley systems in our real world, and you understand how pulley systems work by now, how they gain mechanical advantage, and by how much. And by using more pulleys, you will gain more pulley systems, you will gain more mechanical advantage. So the mechanical advantage you gain is proportional to the number of pulleys you use in the system. And the more pulleys you use, the less effort you need to put in order to lift some weight. And lifting weights is very useful in real world as discussed in the example. So pulley system is actually an essential part of our life, and without pulley systems we may not be able to travel so conveniently between buildings, and we may not be able to live in large tall buildings, and even we may not be able to buy products coming from other countries. So we see how pulley systems is an important part of our world, how our world works. And I think by now we should be appreciating how pulley system has give us mechanical advantage to do work, and by reducing the effort we do in our work to make us more convenient in our real work, in our daily life.